I woke up early this morning to some exciting news. Seestar has now made the S50 and the S30 Alpaca devices. What's Alpaca? Alpaca is a driver that provides the software interface between software applications and astronomy devices like mounts, cameras, focusers, etc. It's the more future-looking version of the ASCOM platform. Now, beyond that, we really don't need to know what Alpaca is in order to take advantage of it. So what does it mean that the Seestars are now Alpaca devices? Simply put, that means we can natively control them on a Windows PC through software like Nina, SGP, ACP, Stellarium, and I'm sure many others. And in order to take advantage of this, you don't need to download any other drivers or software unless you don't already have software like Nina, SGP, ACP, Stellarium, and the others that will work with the Seestar via Alpaca. Hi, I'm Curtis, and welcome to this video. Since I use Nina myself to control my other telescopes when I'm doing astrophotography, in this video I'm going to show you how to connect to your Seestar with Nina so that you have complete control over the mount, the camera, the filter wheel, the focuser, and when nighttime comes, I'm going to do a live demonstration of imaging using Nina connected to the Seestar. Now, before I show you how to connect to and control the Seestar with Nina, you should first note that Seestar, for whatever reason, hasn't yet released this information to the public. And they're on vacation until October 9th for an extended holiday over there in China. So we don't know whether it's in beta testing and they haven't released it yet because they haven't summarized the results, or whether they have found some bugs or issues with the connectivity. Now keep that in mind if you attempt to do this yourself. I can't guarantee that there won't be issues, but I'm willing to try it out myself on my own Seestar and see how it works. Now I found out about this early this morning by a post on cloudy nights and then a link to a video from Queeve, the lazy geek, who went through a very brief demonstration of connecting the Seestar to Nina. So you may want to also look at his video as well. But I'm going to go into a lot more detail. Now, while I'm not going to give a Nina tutorial, there are lots of those online, and I'm really not the Nina expert to do that. I am going to explain the particular parts of Nina that we need to understand when we're connecting to and setting up the controls for the Seestar. And I'm also going to do live imaging with it, as I said before. So for those of you who are not already familiar with software like Nina and SGP, Nina is Nighttime Imaging and Astronomy, hence NINA, and SGP is Sequence Generator Pro. These are the two most popular auto sequencing and automation software that astro imagers use to set up a plan to image one or multiple targets over the night. And you can create a complete imaging session with multiple targets, which will run automatically. You have complete control to set and change exposures, number of frames, the gain, what filters are being used, what targets you're going to go to. You can have it focus and refocus depending on time or different targets. It will also do plate solving and center the objects just like the Seestar does in its own app. So in order for all of this to work, though, Seestar has to be in the equatorial mode on some sort of equatorial mount and polar aligned, obviously. So Nina is a free open source software. It's the one I use and am most familiar with. A lot of other people have been using SGP, which I think has been around a little longer. It is commercial software, so you have to pay for it. But there is a free light version. And ACP is another one of these. I don't really know much about that, but if you have it, you can use that as well. So let's get started. So there's two ways to connect. One is via your home network, which is great if you're at home. Then you can be inside with your laptop. Your Seestar can be outside. and you can set up all the imaging stuff from inside. You can watch what's going on from inside and so forth. If you're at a dark site where you don't have a home internet connection, then we can do this via Wi-Fi, using the Seestar's Wi-Fi. So let me show you that first. So you want to have the Seestar on. You want to be connected to the Seestar via the Seestar app on your phone or your tablet. And then you want to be connected to the Seestar Wi-Fi on your laptop or PC. And my Seestar Wi-Fi is called Curtis Seestar. So it's actually connected now. It's just checking the network requirements, but it's connected. Then we'll bring up Nina, and we'll go under in the camera section, which is located here. It says no camera, and we look at the pull down menu, and it says Seestar Alpaca camera, and then you can click on that, and then we say connect by pressing on this, and then you see it's connected to the Seestar camera. And you see some attributes of the Seestar camera here. There's the pixel size, there's the minimum exposure, there's the size in the X-Y axis of the camera. There's binning here 1x1 at the moment. There's a gain setting. Default gain on my camera here seems to be at 200. I've seen it other numbers. And then interestingly enough, you see the camera temperature down below. And in this case, the camera temperature is about 30 degrees C because it's the daytime, and at nighttime it will be lower. And you can see up here in the upper right, it's 30.5 C. And we have no control over that since this is not a cooled camera. So we are connected to the Seestar. Let's go down here. We can see that we can connect to the filter wheel. So I don't see the filter wheel there. I don't see the filter wheel there, the Alpaca filter wheel. Don't be fooled by this. This is a different ZWO filter wheel. Let's hit the refresh button here. And there is the Seestar. So Seestar Alpaca filter wheel, that's what you're looking for. And then connect. And there's the filter wheel. So you see it there. And the driver for that, driver version. And then you can see it has an IR filter. This is the UV IR filter. It has a dark filter for taking dark frames, and it has the narrowband filter, which is called the dual narrowband filter, which is called a light pollution filter by ZWO. And then next we go down on this column here. We don't have a rotator, but we do have a mount, and it's not there, so we have to do this button here, scan for devices. And then when we do the pull down, there's the Seestar Alpaca telescope. And then we have to connect with this button here, which says connect. And there is the mount, current latitude and longitude, and the site elevation and so forth. And whenever you open Nina and connect to a mount, it's going to ask you, should the settings be synchronized between what the mount's telling it and what Nina thinks it is. And you see a very tiny difference here in the latitude number and a tiny difference in the longitude number. And there's a bigger difference in the elevation. So I would say take it from the mount to Nina. So let the mount feed back to Nina. Could do it the other way. That's okay too. Now you see I have manual controls over here in the lower right hand side. See, this just says it was successful in making the connection. So let's see if we can move this. So you can see by tapping on the east button, it is rotating. By tapping on the west button, rotating the other way. Tapping on the north button, the arm is opening. And tapping on the south, arm is closing. And then if I hit home, See, the Seestar goes to its home position. So if instead of connecting via the Seestar's Wi-Fi, you want to connect via your home network, we're going to do things just a little differently. We're going to go into the Seestar app, tap on the image of the Seestar, tap on the Wi-Fi, Curtis Seestar, and then tap on station mode, and then we turn that on. Then we come back, and we're done with the app here. And now we have to go in to our laptop. We disconnect from the Seestar Wi-Fi. I'm going to connect to my home Wi-Fi. So we're going to go in here again to Nina under camera. Now I want to refresh, scan the devices since I was just connected. And then if you noticed, this number up here changed. I was connected via the Wi-Fi. Now I'm going to connect via the home internet. So this is a different IP address. So go over here and hit connect. If you don't do that, you won't be able to connect it. It'll be looking in the wrong place. So you see the same stuff here that we saw before, temperature of the sensor and so forth. Here's the filter wheel. Again, this is from the previous Wi-Fi setup. So we want to hit this refresh, scan for devices button. And then now you see the Alpaca via the home network and connect. And we are there. Go to the focuser, same thing here. Scan again. And now we'll go down here, and that's the right one. Connect it. And last is the mount. And do a refresh here. We've got the right one there. Connect. And now the mount is connected, and everything is connected. And again, we can open the mount, move the mount, can open the arm, can do all those things, and then can head back home. I'm not going to use the park position because I'm not sure whether the park position is defined as the home position. Seestar's already created the home position. So, all right. So there you have the two different ways to connect software on your PC to the Seestar. Using the Seestar's Wi-Fi with the station mode turned off on the app, or using the station mode turned on the app and connecting to your home internet. In the first case, you connect to the Seestar Wi-Fi. In the second case, to the home internet. First case, the station mode is off. Second case, the station mode is turned on. And it'll work either way. And then you can connect with Nina. And I suspect it's very similar for SGP, ACP, Stellarium, Cartes du Soleil, any of those programs that will work with this. We don't, at this stage, since ZWO hasn't announced this feature, we don't know all of the programs that it'll work with until people try them and post online, or ZWO comes out and tells us. As I said in the beginning, this is not meant to be a Nina tutorial, but in order to make this worthwhile, I am going to go through the settings on the camera, focuser, etc., and show you what I think those settings should be when using Nina with the Seestar. And some of those we can set ahead of time. It's not really a lot of guesswork. Some we are going to have to make a best guess, especially with the focuser. And when I connect to the Seestar at night, I'll be able to test out those settings and make adjustments if they aren't quite right. So let me just show you a couple of basics here on Nina in case you don't know. There is a Nina manual that can help you get started. There's a lot of tutorials on YouTube as well. And you can also consult the manual on some of the settings if you want to better understand what those settings mean and why I chose the ones I chose. So in Nina, the way you set up the information that Nina needs to know about your astronomy equipment is through profiles. And we have here a number of different profiles that I use. So the first one here is my Software Abyss Mighty mount with my Celestron C11 at f2 using an ASI 2600 color camera. And so if I tap on that and hit load profile and then go into this page here with the telescope icon, you can see it tells me all the information that I need to know about the camera, the telescope, the mount, and so forth. So let me go back into profiles. I started to set up one specifically for my Seestar S50 at home. Let's load that profile. All right, that's the profile over here, Seestar S50 at home. When I say at home, that's because down here I have my latitude, longitude, and site elevation. If I were at a dark site, I'd have to put those numbers in here. When we set all of this up, we don't need to be connected to the telescope, or in this case, the Seestar. So we can go in and fill out the information about the particular hardware in the Seestar. So I've already pre-filled this out. So the pixel size, 2.9 microns, the bit depth, 12 bits. The bear pattern, I believe, is RGGB. I looked that up on another vendor's site. And if that's not the case, we'll learn very quickly when we start taking images. Telescope name, the focal length, 250 millimeters, and the focal ratio, f5. Also, the mount name, Seestar S50 in this case. This settle time after slew, I leave it at 5 seconds. That's what I use with my setup. It just allows Nina to wait until any vibrations from the slewing have dampened out. Over here, we see the filter positions. This is automatically populated from the previous connection to Seestar itself. Down here, I want to point out the planetarium. Nina has a large database of deep sky objects, but you can also use other planetarium programs like I use the SkyX. You see Stellarium in here and others. You could add that to the mix as well. So that's the camera, telescope mount. We need to also go down here for plate solving. So this icon down here is the plate solving page. We're going to have Nina do the plate solving, not the Seestar. And so it needs to have a plate solver engine. And I typically use ASTAP, ASTAP. And that's free to download. Just Google it. You can download it onto your PC. So that is a piece of software, if you don't already have that loaded, that you will need. You don't have to use ASTAP. You can use All Sky Plate Solver. There's some other ones as well. ASTAP is probably the most widely used because it works pretty well. And then same for the blind solver. We won't get into the details. Here are the settings for doing the exposures for plate solving. Those obviously will depend on the setup you have, the camera, the optics. This is a carryover from what I had with my other telescope. We'll leave it at that. We can adjust that if there's a problem. So that's the plate solving. Then the next thing is going to be the autofocuser. Now, since I don't have prior experience controlling this focuser, none of us do in the Seestar, we're going to have to guess at some things, but only a couple of things. Most of these, we're going to use default values. So no filter offsets, that's off. Autofocus initial offset steps, that means how far out to go before it starts coming back and taking images and building the curve out. 4 is a good place to start. The autofocus method, half flux radius of the star, that's a good default value. The curve fit, hyperbolic curve. There are other choices as well, but hyperbolic curve is probably where you should start. The number of attempts, I have it set to 1. You could set it at 2 if you like. If it fails, it'll just keep the current focus that it has, focus position it has. Use the brightest N stars. So if you put in here 20, it'll use the brightest 20 stars for focusing, or 10 would be the brightest 10. If you put 0, it's counterintuitive. It doesn't mean it won't use any stars. It means it will use all the stars. Now, the crop ratio, there's an outer crop ratio and there's an inner crop ratio over here. So I have this set to 1 and 0.9, which means the autofocus will not use the outer 10% portion of the frame for focusing. So it ignores stars in the outer 10% of the frame, which I think is a good thing because there's where we're going to have the most probability of distorted stars and out of focus and so forth. So we're going to throw that out. You don't have to do that, but that's what I do. Binning, we're going to leave this at 1 by 1. And the R squared threshold is, that's the other thing here, is if you just hold this here, you'll see a little information about what this stuff means. They're suggesting a good starting threshold is 0.8. I've been getting away with 0.7. I've been very happy with the focus of my stars. You can set it to 0.8 as well. So it'll fit the curve, see how well the curve fits the data. And if it's not within that threshold, 70% or 0.7 or 80% 0.8, then it will either do it again if you have the number of attempts set higher than 1, or it'll just default to the current focus position. Autofocus step size. This really depends on the focuser itself and also on the gearing. So 50 is what I use for my Celestron motorized focuser. With my Celestron SCT, this number is probably way too high. I'll try it, I'll look at the focus curve, and then I'll make adjustments. The default exposure time, 2 seconds. That's a reasonable place to start. We're not doing autofocus, we're not doing guiding, so we don't have to disable autofocus during guiding. The settle time, in case you think the focuser causes some vibration, I'm leaving that at 0 seconds. The number of exposures per point, you can make this 2, 3. It'll just take much longer to do focusing. You'll spend a lot of your imaging time focusing. 1 seems to work fine for me. Talked about the intercrop ratio. Backlash compensation, there's 2 methods here. There's absolute and overshoot. If you leave this on here, it'll explain what those are. I use overshoot, so it basically goes past and then comes back so that it takes out slop in the gears. And then the backlash, you have to put a number in one of these 2 positions, either in the in, backlash coming in, or backlash when the focus is going out. So I have it on in at 10. And again, this is going to be highly dependent on the particular focuser and the gears in the scope. So these 2 things I'm going to really expect. I may have to change, I'm going to have to change those, but I only will get an idea when I actually do some focusing tonight when it gets dark. So those are the parameters that you need to set up for the Seestar. Hopefully we can get a good focus and we can figure out what numbers are best here. And then other folks don't need to repeat this. They can just copy these numbers down. So I have the Seestar set up here in my backyard in equatorial mode. When it gets dark, I will polar align it, and then I will connect it to my PC via Nina, and then we can do some focusing and see if we have the right focus settings, and then change those if we need to. And then once we get good focus, we'll see if we can have Nina go off and do some imaging for us. So after spending a lot of time adjusting the autofocus parameters in Nina, I think I've been able to get this to focus reasonably well. You can see I'm using the field of view with M27 in it to do the focusing. And the first thing to notice is that over here we have the filter, the IR filter. Even though you may be using the light pollution filter for something like M27, you don't want to focus with the light pollution filter. That won't work. You need to switch to the IR filter and hit the change so that the Seestar is got the IR filter in place. And if you notice how the Seestar app itself focuses, it does not use the narrowband light pollution filter even when it's looking at emission nebula and other things, that it will eventually use the narrowband filter for when it's collecting images. It doesn't focus with that. There's an offset built in, so I believe what it does is once it focuses with the IR filter, it then puts an adjustment in there based on factory settings to get it in focus with the other glass in the narrowband filter. Also, let me go back to the settings here. Now, it turns out that I definitely had to make some changes to the setting. The first big change is the inner crop ratio. I had that set at 0.9. That doesn't work at all. You'll never get it to work. I don't think you'll ever get it to work. So I set this back to 1, so there's no cropping going on. We're using the whole field of view. Also, I eventually came up with an autofocus step size of 15 and the backlash on the in at 6. It's not perfect, but this works reasonably well. If we go into the imaging part of Nina, and here's the autofocus here on the right, I set this to a position 1550 on the focuser, which is on one side of focus, so it's out of focus right now. If I took a new image here, you would see it's out of focus. So let's start in fact, here is the focus position from my test runs. So let's start the autofocus routine and let it do the points. So it's going to do 4 points on either side of focus. So you see it started down here in the lower left at 1505. And there's the half flux radius with some air bar on it. So it dropped it down from 1505 to 1490. That's the step of 15. You see several more points here. Starting to see the shape of the curve. So it has plenty of points here on the one side of focus, looking for the bottom. You can see the inflection point is just below 1600 on the focuser. And now on the other side of focus. So what Nina will do is it will take at least 5 points on either side. If it has to go backwards, it will go backwards. If it didn't start far enough down, but in this case it started further down than it needed to. And that's all determined by the starting focuser position and the step size and the number of steps. Alright, so it's finished. But it has 5 points on this side of focus and more than 5 points on this side of focus. And you can see the focus position 1590, and the R squared for the curve fit is 0.98, so that's quite good. Now I'm going to go to the other side of focus, so we're going to go to 1650. So I'll go over here and set the focuser to 1650. We'll move it there, and then you'll see up here it's at 1650 right there. And we'll start the autofocus again. So it's now on the other side of focus. I think this curve won't look quite as good, and that's the limitation of the settings that I have, and it may also just be the limitations of the Seestar gears. There's the first point, and what it's displaying here for people who don't know is the half flux radius. So it's a measure of the size of the stars in terms of the number of pixels that they consume that are required to display the star. Now for those who are new to these autofocus routines, you have to be reasonably close to focus, at least close by eyeball, because if you're way far off, they're not going to be able to converge. So get the focus close. Well, you see it got a nice curve here too, 1590, and the R squared is 0.96. So I'm pretty happy with that. Again, here are the settings. You can try these settings. I used overshoot and I used the backlash on in, and 0.7. I could have raised this up to 0.8 because you saw that the curve fit was much better than that. Now, another thing I want to show you is the plate solving. So up here in the right hand corner, we can bring up the plate solving routine here. So this already has got a plate solution, but let's do this again. So it's gonna do a 2-second exposure, and then it's gonna, and it's, you see it knows the arc seconds per pixel, so it knows the image scale based on the information we put in there about the focal length and the pixel size of the camera. So let's go ahead here. If you look in the lower left, it's doing an exposure, so it's telling you here what's going on, downloading the image, stretching it, solving it, and it says success, so it found where we're pointing. So it has the right ascension, the declination. So plate solving works using Nina. And let's also do one other thing. So if we go to this page here, the left column, second icon down, this will allow us to pull up different objects. M33, for example, and to put that in as a galaxy and hit enter. And there comes M33. So it gives us the information on M33. Looks like it's won't transit for a few more hours, so it's on the rise. We can tell it to slew to that target, so let's just have it slew to the target. We look here, we see the right ascension 1 hour, 33:51, and the declination 30 degrees, 39 and 36. If I go back to the imaging page, you can look at the mount, and you can see it should be right about there now. So let's just do the 30-second. I set the imaging to 30-second here. Let's do a 30-second image and see if we've got it. All right, so there's M33, at least one frame, one 30-second frame. So we've demonstrated that we can connect to the Seestar with Nina. We're able to connect to the camera, the mount itself, focuser, and the filter wheel. We're able to slew to objects. We're able to plate solve. We're able to focus. We're able to image. And there's a lot more we can do, but that's beyond the scope of this first video on the topic. So I think that's pretty exciting. I think it opens up a lot more opportunities for us when using the Seestar, especially if you're trying to do astro imaging. It's not so much for electronically assisted astronomy, so live stacking. Seestar does that quite well. But this would be for those of us who want to set up the Seestar and take lots and lots of frames and then post-process them later. So we can take a look at other features in the future if that's of interest to folks. So I think it's pretty cool that we now have the ability to use the PC and sequencing programs like Nina, SGP, and so forth with our Seestars. And there you have it, a first look at running the Seestar with a PC, in this case using the Nina nighttime imaging software. I hope you found this video useful. If you did, please don't forget to like the video. That makes it easy for others to find it. You may also want to subscribe. Also, please leave me some comments down below if you would like to see me show a little bit more about how to use Nina with the Seestar. I can think of a few more simple videos that will be helpful for folks that are just getting started with Nina and want to use that with their Seestar. There's a whole lot more we can do with Nina, setting up sequences just like we do with the plan mode in the Seestar app, only much better, and so forth. So let me know if you would like to see more of that kind of stuff. And if I get enough positive feedback, I can produce videos on those topics as well. So thanks again for watching, and until next time, clear skies.